Algebra 2 Notes 7.3 Logarithm Functions as Inverses. What is a logarithm? To find this out, we're first going to watch a video.
In this video, I'll explain why we use logarithms and how you calculate them. A log asks, what's the exponent? Log base 10 of 1,000 asks, 10 to what exponent is 1,000? A log asks, what's the exponent? Logarithms are useful for dealing with things that are exponential, because the exponential, that's where the x variable is in the exponent, get very, very big, but also get very, very small. The y value out here can be 0.0000000000001, very small, or 1,000,000,000,000,000 out to the billions and trillions and quadrillions, very big. When things are very small and very big, you want to ask, what's the exponent? Because writing out the regular number can be too small or too big to be easy to handle. It's much easier to ask, what's the exponent? Logs ask, what's the exponent? Things that get very big and very small are, for example, sound or earthquakes. Logarithms ask, how intense is the sound? Or how big is the ripple from an earthquake? The logarithm asks, what is the exponent? And gives us a nice way to deal with really big and really small values. But how do you calculate them? Remember, 10 to the third, in that expression, 10 is the base, and 3 is the exponent. 10 to the third is a shorthand way of saying 10 times 10 times 10. 10 to the third is 1,000, because 10 times 10 times 10, 10 multiplied by itself with a total of 3 factors of 10, 10 to the third is 1,000. So the logarithm, base 10 of 1,000, asks, what's the exponent? 10 to what is 1,000? The logarithm, base 10 of 1,000, is 3, because 10 to the 3 is 1,000. The logarithm asks, what's the exponent? And the exponent there is 3. So the logarithm is 3. What about this problem? What's the exponent? 1/2 to what is 1/4? Well, 1/2 times 1/2 is 1/4, so 1/2 squared is 1/4. The logarithm, base 1/2 of 1/4 is 2, because what's the exponent? When the base is 1/2, the exponent has to be 2 in order to get 1/4. Logarithm asks, what's the exponent? We use logarithms to deal with really big and really small numbers at the same time. How do we do it? By asking, what's the exponent?
Okay, so a logarithmic function is the inverse of an exponential function. So if you have an exponential function that says b to the y equals x, we can rewrite that as logarithmic, which logarithm base b of x equals y. So right now we're just going to practice writing each of these in words. So this first one in words, log base 3 of 4. That's exactly how we write it out. So it'd be the logarithm, or log for short, at base 3, log base 3 of 4. So go ahead and do the next two. Pause the video. Log base 2 of 16 and log base x of y. So what we're going to do next is take these exponential functions and write them in the logarithmic form. So again, we're just practicing. We're not solving anything out. We'll evaluate those in a little bit. All right, so since the log base b of x is your y, we can rewrite this. 3 would be your base here, so we can rewrite it as logarithm base 3, so that's a subscript of 9 equals 2. Okay, so it's just, you can go back and forth from exponential function to logarithmic function. Okay, now we don't have a button to do this on our calculator, so that's why we need to be able to bring it back to exponential. We can do logarithm base 10 on our calculator, but not logarithm base 3. All right, this next one would be logarithm at base b of x equals y. Remember, a logarithm asks what's the exponent. So your answer is always going to be that exponent. So, for example, in this one, your exponent was y. That's going to be the answer when I make it logarithmic. The exponent was 2. There's the answer in the logarithmic form. Just like that video said, a logarithm asks what's the exponent. All right, go ahead and pause the video. Try the last two. All right, log base 2 of 16 is 4. Log base 10 of 1000 is 3. Now this is the one you can do on your calculator. So if you want to grab your calculator real quick and type this in. So on your calculator it will not say base 10. So when you have logarithm just written by itself, that's assuming it's base 10. Similar to when you have a square root, we don't write the little 2 out there. This is the most common logarithm. It's called the common logarithm when it's base 10. So you don't have to write it if it's base 10. So go ahead and try that on your calculator. Log of 1000. So log base 10 of 1000. And then you should be getting 3. Okay, let's go ahead and evaluate logarithms. What is the value of each logarithm? So this time we're going to go backwards. We have it in logarithmic form. We want to put it back into exponential form so that I can solve it. So remember, a logarithm asks, what's the exponent? So let's go ahead and say, okay, a logarithm asks, what's the exponent? That's the answer to a logarithm. So when I put this in exponential form, I'm going to take that base number to the x power. Okay, a logarithm asks, what's the exponent? There's your exponent, equals 32. Now setting this up is new for us, but also solving this type of problem is new for us. So how would we solve 8 to some power equals 32? Well, what you want to do is try to get these sides to each have the same base. So what would the same base be? Well, we can rewrite 8 as 2 to the 3rd, right? And we can rewrite 32 as 2 to the 5th. Going back to our exponent rules, if I have a power to a power, I'm just going to multiply those. So 2 to the 3x equals 2 to the 5th. And then you can just set the exponents equal to each other. Because if I have 2 to the, think of a different example here. If I have 4 to the 2nd and 4 to the x, that x must be 2. So as long as your bases are the same, you can just set those exponents equal. All right, so last step here, we want to get rid of the 3. So we're going to divide both sides by 3. And again, we don't have a way to check this on our calculator. Logarithm base 8 of 32 at this time. We'll learn something in a couple sections, but right now we don't have something that can double check it. But what you can do to check your work is you can take 8 to the 5/3 power and see if that gets you to 32. Okay. Okay, let's try the next one. So again, a logarithm asks, what's the exponent? So if I put this back into exponential form, that answer to the logarithm is the exponent for your 5. So if it's something like this that you can easily figure out 5 times 5 times 5 is 125, you can just get the answer, but you can also kind of model this the same way we've been doing it and thinking of 125 as 5 to the third. So then our exponent must be 3. So logarithm, we don't have a way to do this on our calculator, but now we figured out that logarithm base 5 of 125 is just 3. Okay? All right. Why don't you pause the video and try the next one? Okay, this one's similar to the first one we did up here. So 4 to the x equals 32, we can rewrite 4 as 2 to the second, 2 to the 2x equals 2 to the fifth, and then again set those exponents equal to each other. So divide by 2, x is 5/2. Okay, so again, logarithm base 4 of 32 is 5/2. To check your work, we can't do that on the calculator, but what we can do is see, is 4 to the 5 over 2 the same as 32? Okay, and we could even rewrite this as the square root of 4 all to the fifth. Did that equal 32? Yes, 2 to the fifth is 32. All right, this last one, logarithm asks what's the exponent. So our base is 64, our exponent is x, and then we were left with 1 over 32. So again, you want to try to think of some numbers that 2 to this power, 4 to this power gives you 64 and 32. So I'm thinking 4 to the third is 64. 4 times 8 is 32, but times isn't going to work. So we're going to have to go down to 2. So 2 to what power is 64? So we know 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth would be 32. 2 to the sixth would be 64. So we can rewrite 64 as 2 to the sixth all to the x power. And the 32, it's still going to be 1 over 32 was 2 to the fifth. All right, so remember to get that base up to the numerator there, I'm going to have to actually make my exponent be negative. So we'll leave this left side 2 to the 6x. The right side, in order to set these equal, we have to have our bases both be on the numerator. So we can rewrite that 2 to the fifth power that was in the denominator as 2 to the negative fifth by moving it to the numerator. From there, then now that our bases are the same, we can just set those exponents equal. So we'll go 6x equals negative 5. Okay, so x equals negative 5 over 6. All right, your assignment today is a textbook assignment. We're going to skip the second page if you want to look into it. I will post the notes to it, but you can just jump to the assignment, and then we are not doing the second part of the assignment. So you don't need to do any of this. Okay, so just doing 12 through 27. So the 12 through 19, you're just practicing writing those in logarithmic form. And then 20 through 27, those are like the ones that we just got done doing.